Hello, in this video, I'm going to show you how to search and download NASA Earth data products. The NASA Earth data portal hosts a lot of Earth observation data on AWS, and they provide a website where you can download data interactively. But sometimes, if you're downloading a large amount of data, you might want to do it automatically. So I've integrated some functionalities in Leafmap building on top of the Earth Access Python package. So in this video, I'm going to show you how to access that easily, and you can download a lot of data without having to use the graphical user interface, because those are usually for small amount of data. And if you go to the NASA Earth data website, you can look at some of the data products available. There are all kind of data, so you can find data here using different topic. So basically what we're going to do is using the API, but we have the Earth Access Python package that makes it easy for us to download the data. You're welcome to check out the website. And in order to download the data, you will need to actually sign up for an Earth data package, Earth data login. I'm going to show you how to do that. So next, let's head over to the Leafmap package, leafmap.org. And if you click the notebooks, scroll down to find number 88. And in here, you're welcome to download this notebook to your computer, or you can just open using Google Colab or other cloud computing environment here, AWS SageMaker Studio Lab, or Microsoft Printed Computer. And once you download it, you can, if you already know how to set up the Python packages on computer, you can install it. Otherwise, the easiest way is to just open Google Colab, and then you need to install the Leafmap Python package. So here, I already opened the Jupyter Notebook using my Jupyter Lab. So if you double click, it's going to show you here. Let me clear all the outputs because I just tested earlier. And here, the notebook basically has two sections. The first section, I'm going to show you how to search the data programmatically. And the next one, I'm going to show you how to search the data interactively and also download the data. Again, if you don't know how to install the package, you can just create a new code block and then pip install Leafmap, and then shift enter. You should be able to install this Leafmap package into the cloud computing environment, Google Colab or SageMaker Studio Lab. So let me remove this one. And once you install the package, then we can import the libraries. The next step is to log into your NASA Earth data account. So if you don't have an account yet, click the link here. It will take you to the website, Earth data login. Here you can sign up, just register. Choose whatever following instructions, and then sign up for an account. Once you have the username and password, then you can come back to here and then run this code block. It will ask you, if you have not authenticated yet, it will ask you to enter your username and password. So in here, if I click Shift tab, it's going to show you here strategy, or it's going to basically, for example, try the interactive mode. If it doesn't detect the system environment variables. So if you can also, if you know how to set environment variables. So for my case, I set the environment variable on my computer, and then you automatically detect the username and the password so that I don't have to enter in here. And as you can see, if you set it up correctly, it will be authenticated. Otherwise, you're going to throw errors. And so once it's authenticated, then we can look into the data. So the first one to show you here is that I create a repo called NASA Earth data. Basically, it's a CSV file that shows all the data products. If you click the link, it should take you to this website, the GitHub repository. So this is the one I created last month, showing you basically what data are available by NASA. And if you click this TSV here, so this is basically a tab delimited files. It's a huge file, and it's not very user friendly, but I'm going to show you how to read it using pandas. So essentially, this one is a repo that automatically retrieves data every 24 hours. So if NASA updates any data, it will be showing up here. It will be automatic. So you can see I run it automatically every 24 hours. So it's automatically updated. Of course, if you want to see what's updated, we're going to come here and then click to load the difference. But usually you don't have to because you can just use Leafmap. So Leafmap will pull the latest one from this CSV file. So you can see probably update the DOI and then some data, and maybe also update the date, something like that. So what we're going to do here is actually to just read the TSV file. So this coming from this GitHub repo here, just to show you. Go back. So basically it's reading this file. The link comes from the rule. So if you right click and then copy the link, come back to the notebook here, basically this one. And we want to read that using pandas. And this is tab delimited. So that's why you need to have \t here. And just shift enter. It will download the file and then read that using pandas. Here you can see in total we have 9,030 data products stored in the NASA Earth data. So this is a huge data set. Each data set has a lot of data in there. And you can see the table, the name. So what we're going to do here, the short name, basically you can think about the unique ID to the data set. So in order to source the data, you need to provide something, the short name, the DOI, the concept ID or something like that. Basically it's a unique ID that can identify the data set. And there are some other additional information, the S3 bucket and the bounding boxes and also the resolution. Not all of them have all the complete information. So there might be some missing data, but essentially at least you can see some of the spatial temporal information. And also at the end here, there should be the link showing you the DOI. So if you want to, for example, copy this, and then you can get to the dataset if you want. So Control C and then Control V, hit enter. It should take you to the website. So this one shows you after you do the search, for example, read the table, you can see the metadata information in there. And once you have this data table, what we need to do is to figure out the user, the short name. So if you already know the name, if you go to the NASA Earth website, and for example here, you'll be this will be the unique ID to the data set. And what we want is to get this short name and then passing to the next code block here, Leafmap NASA data search. Okay, so this one built on top of the Earth Access Python package. And so you're passing the name. If you click Shift Tab on your keyboard, it will show you all the information in here. And cloud hosted means this is hosted on AWS cloud. The most important one probably you need to provide is the short name, the bounding boxes, and also the temporal. If you don't provide, you will search at the global scale and also all the time periods. Sometimes it might be overwhelming. So in this case, I'm just searching the data around these bounding boxes. So this is the lower left corner and also the upper right corner. Oops. So this is X min, X max, Y min, Y max. So this will be the longitude, lower left corner, longitude, lower left corner, latitude, longitude, latitude. And then the date, something like this. You can also pass in the time if you need the time. The count equal to -1, that means you're going to get all the results. But sometimes you only like 10, 20, you can just change this one number to whatever number you need. And then lastly, whether or not you want to return the result as a geodata frame. Usually we want this one because we want to visualize the result. So if you return it as a GDF, that means the result will be a results object and also the geodata frame. If you don't need it, you can, by default, it's going to, I think by default it's true, right? Or it's false. So if you don't specify, then it's going to just return a results object as a list. So let's run this one to see how many data in here. In this case, in this bounding box, in July 2020, it has 259 granules. So that means 259 images. Keep in mind here, because we have the geodata frame, so now we can actually visualize that using the explore function, the built-in function in GeoPandas. So right now, if you run this one, take a look, right? So essentially, we have the bounding boxes, and then we're going to get all the images intersect with this one. So if you hover your mouse on the map, it's going to show you all the metadata information that we query from the data. Of course, some of those are quite complicated. You can see it's a list and within the list is a dictionary. So, but once it's a geodata frame, you can save it to a vector data, GeoJSON shape file, geo package if you want. But sometimes if there's a complicated data structure in the metadata, you might not be able to. So you might need to clean up the data. And once you find out the data covering your area of interest, then you can download the data. So there's another function, leafmap.nasa data download. And if you press Shift tab, you can again see the help documentation here. Granular, so basically it's a list of the results object where when you want to output. So all we need to specify this one if you want to like download multiple images all together with multiple threads. By default it's 8. So basically you can download 8 all at once. And so we're going to set here the output folder going to be data. So it's right now on my left side here. We don't have the data folder yet, but you will create the data folder. And since the results object is a list, so right now we have 259. It's going to take a while for me to download all the data. So I'm just going to download the first 5 as an example. And you just Shift tab, you see, it's going to query. It's going to show you approximate what's the file size. So this is almost 1 gigabyte. It's going to download slowly, depends on the internet speed. But you see, it's pretty easy and straightforward. So all you need to do is basically just customize this function to whatever data set. All you need to do is go to the NASA Earth data, search in here, and then find any data set you like. After that, you should be able to get the short name, the concept ID, whatever, and then come back to this function, replace this one, replace your bounding boxes. If it is global scale, then you can just skip it. By default, it's none. And the temporal and how many images you want, whether you want to return as a geodata frame or not. Okay. On the left side, you see the directory has been created and it's downloading all the files. So these are actually H5 dataset. And you see some of those are 20, 40 megabytes or 95 megabyte, and it's still processing. Let me open my file explorer here, and if you go to data, see, so the SHA-256 is just to verify. Oh, it's just still downloading, so it's not finished yet. But this one basically to verify that the data is unique, is authentic. And once it's done, then you should be able to read the data using Python packages, for example, X-ray or whatever Python packages that you need. And if the data has already been downloaded, you will skip that. So unless you want to overwrite the data. So by default, this function, it will only download the data that do not exist. So if the file already under this directory, it will not overwrite. So you see here, my internet is not very fast, but at least you can see it's still running. So we have, because we're only downloading the first 5 in here, and that's why we only have 1, 2, 3, 4, 5. If you download all of them, you're going to have all the files listed here, but the maximum one that I'm downloading is by default is 8. So if you're downloading, for example, 100 files, it's going to be 8, and then finish, and then go to the next one. So basically, but simultaneously, you can specify. So if you have a better computer, you can increase the thread to get more, but it's going to use more, of your internet bandwidth. And it's still processing, so almost done, 90%. As you can see, this is a lot more flexible compared to you using the website to source the data, because you can customize, you can be very precise about the bounding boxes, the temporal, and also how many do you want. Okay, it's done. And one, I'm going to here, the next one, one step forward. You don't need to import this one. This is mostly just for the documentation website, so it doesn't fail, because by default it's importing the Folium library. And if I come back to here, right now I just run this one. So create a new map and then just map.add NASA Earth data. It's going to add this graphical user interface to the map. And so this is an interface that I integrated into Leafmap, so it makes it easy. The reason for that is that for the short name here, right? Sometimes it may be a bit difficult to remember what it is, and there's no way that anyone can remember the entire list. So this one again is come from this NASA Earth data repository, and that's the reason why I built this one, because I want to get the list of all the short names or the concept ID, something like that. So then anytime if you run this one, it's going to put the latest list. It's always going to be updated. So it's going to read the list basically under the hood. It's going to run this one. So if the list is updated, you will get the updated list. And let me come back to here. All right. So once you have this, then you can select whatever data set you want, right? So earlier we used this one, JEDI 804A data products and ground biomass. And this one shows you the title. This one you cannot change, so it's disabled. And also maximum, how many results you want to return. So basically earlier we used this one here, right? The count, how many? -1, that means it's all of the data set. 50, that means, okay, I just want the 50. And so we can either draw a rectangle, or I can just simply zoom into this location. And basically, you just change the, select the data set you want. You don't need to do anything else. Just click search. Okay, it's going to search all the granules within this one. So you see, in total, there are 12,000 images covering this area. But because I said the maximum is only 50, that's why it's only showing you 50. But in reality, there's a lot more. So if you zoom in to maybe a smaller area, let me reset here and then search again. Right. So right now it's 2,000. Of course, you're welcome to continue to search anywhere you like. Right now it's 400 and something like this. So reset. You can also map mouse. So if I think if I draw a rectangle somewhere here, it will also specify search the data within a rectangle. So again, let me do the search. You see? Oh, it's more like the map mouse. You will need to provide, I think, the bounding box coordinates. So basically the x min, x max, y min, and y max. Anyway, so let me remove these bounding boxes. So assume, okay, this is all of them. And if you really want to see all of them, I can change to -1 and then just search reset. You see here, -1. That means you're going to search all the data sets. So search. This is sometimes might be slow because you're adding a lot of polygon. You see, it's a lot more data set, and it's certainly a bit overwhelming. But if you really want to, this is what you can do. So let me reset. How about this? We can specify the date. Okay, just like what we did earlier, right? We can specify whatever date you want. So I can see, for example, 2020, July 1st, and then to again 2020, July 31st. Okay, and then I can search again. So this right now you only showed the dataset within these bounding boxes. So if I try again, search, it's going to increase more. So it's dynamic, so you don't have to do a lot of coding. So this one basically is just one line of code. Add this one, then you should be able to do that. So in total, this is what we have. And once you have this one, then you can access the search result. So map._NASA data GTF. So if I run this one, it's going to show you here. This is in total we have 50 because we set 50. So 49, 50 rows in here, all the data set. And similar to what we did earlier, the size, you can see how big are the file size in here, and the concept ID, and also all the metadata information for each one. So this is how you can search the data interactively without coding. And lastly, if you want to download the data, so similarly, right, just like what we did earlier, NASA data downloaded, and also the results, and then you can just run it. It should be able to download all the data set. So let me try in here just to show you the output. So for example, I only show you 5. So search the result. I show you just 5 files. And then, so right now, if I run this one, it should be only just 5. And then I can run this one. So I can download all the data set. You see some of those are already downloaded. So JEDI, but there are some new ones. So you want to be able to download whatever data set. So again, like this one right now is 1.04 gigabyte. And some of those are downloaded. Some Already downloaded. Yeah, most of those are already downloaded. Okay, so this is what you can do, but you're welcome to change to other data sets. Let me let this one finish, then I can show you the other data set. Again, you can click the list. You can switch to any data set you like. You can also do the keyword search. So if you have specific data set in mind, you can do that easily. Let me wait for this one to finish. Let me see here. Still downloading. So each file you see is like over 200 megabytes. So it's a pretty large file. So make sure that your internet speed is okay. Otherwise, just download first couple files so that it's not wasting too much time. And a couple more seconds, and then it should be done. Again, if you have any data set in mind, just remember that you can come here, just use this code block, add NASA Earth data. The next one I will show you. I can reset. Okay, it's done. So I can try, for example, let's say I want the NASA nighttime light data. It's not working. I think it needs to be wait until this one is finished. Okay, it's done. So search. Oops. Let me run this one again. I think earlier it's not. Sometimes if it's stuck, you can rerun it. So again, I'm gonna try nighttime. Hit run. Okay. There might be some bugs. Let me restart the kernel. And then run this one again here. Hopefully it should work. Okay, I'm try again. Nighttime. It interesting. Let me see. Oh, nighttime. So there's a typo in here. Okay. So if I type nighttime, and then now you see these are all the images that has nighttime images. Of course, you need to know the data products. And for example, I can just select, how about this one, last one. And zoom to any location you like. So this is where you want to find out your area of interest. You can either use the bounding boxes, provide the coordinates, or you can use the map bars. So here, you can specify the number of maximum items. For example, I want 100 images. You can specify the date if you want. Otherwise, just click search. It's able to search and return all the bounding boxes. Okay, so right now here, we only have 5. And you can see all the data set available. So in total, there are 88 images. So they're all from here. Right now, you can only see the list. So in the future, hopefully I will add more functionality, allow you to visualize the data. But for now, just showing you, for example, this is the output of all the data set. Let me reset, right? So again, I can zoom in here like this. And again, nighttime. Okay, and I'm going to select, for example, some of the data set here. 50 is fine. So search. Okay, so this one has a little bit more in here. So right now has a total of 12. Okay, and there are a lot more images in here. Similarly, once you have this, you can run this one. You should be able to see the output. So in total, there are 50. Because we set the maximum 50. And then after that, you can specify here to download the data, again, similarly to your computer. So in this way, you just explore the data interactively and then find out the data that you want. And then you can access the geodata frame, or you can download the data directly to your computer for fuller data processing. Okay, so that's all I want to show you in this video. I hope you find it useful. I will see you in the next video. Take care. Bye-bye.